Greetings to all the students. We are once again here with the new chemistry topic, isotopes, and this is actually a part of the topic of atomic structures. So we have seen in the structure of atom that elements are actually those type of the substances which are made up of all the identical atoms. The atoms in the elements are all same. They are carbon copy of each other. They are mirror image of each other except one thing, and that is number of neutrons. So in an element, all the atoms are exactly same, just their number of neutrons slightly vary from atoms to atoms. Such type of the atoms in an element are called isotopes. All right. So you can see that every element has got isotopes. Every element have got such type of the atoms with different number of neutrons. We can see the example of hydrogen. Hydrogen has got 3 isotopes. So you can see in the picture, the first example is called, the first type of the isotope of hydrogen is called protium. So what is protium? In protium, in this type, there is 1 electron, 1 proton, but it does not have any neutron. So 0 neutron. All right. So what will be the atomic number? Atomic number is the number of proton. So atomic number is 1. What is atomic mass? P plus N. So proton is 1, neutron is 0. So atomic mass is 1. Similarly, the second type of the particles are called deuterium, in which there is 1 electron, 1 proton, and 1 neutron. So in this case, the atomic number is the number of protons, so that is 1. And atomic mass is P plus N. So 1 plus 1 will be equal to 2. The third case is 1 electron, 1 proton, and 2 neutrons. So the atomic number is 1 and atomic mass is 1 plus 2, 3. But in the periodic tables, you will see that hydrogen is written like this. What does it mean? Atomic number 1, atomic mass 1. Why? This is actually protium. The reason is that 99.99% of the particles in the sample of hydrogen is protium. And these are so less in number that they are negligible. So we just neglect these two and we consider that hydrogen, most of the particles have got 1 electron, 1 proton, and 0 neutron. That's why in the periodic table you will find that hydrogen is written with atomic number 1 and atomic mass 1. So this is one of the examples. Hydrogen is the first element of the periodic table and it has got 3 isotopes. Second example is the chlorine one. Chlorine has got 2 isotopes. You can see over here. One type of the chlorine particles have got 17 electrons and 17 protons. Remember that the number of electrons and protons will always be same. But the number of neutrons are 18. So the atomic number is the number of proton, that will be 17, and the atomic mass is P plus N. So 17 plus 18 will be 35. So these type of the particles. And another type of the particles, same 17 electrons and 17 protons, but number of neutrons are 20. So it will be chlorine, 17 and 20 plus 17 will be 37. But you will notice one thing, that in the periodic table, it is written like 17 atomic number and 35.5 is the atomic mass. How come atomic mass of something can be in fractions, can be in decimal? Because atomic mass is proton plus neutron. So proton and neutron are the whole numbers. Nothing is half. So how come this half is added over here? Proton are not a single proton is half, not a single neutron is half. How come then it has become half? We have to do a small calculation. So how we will do the calculation? Now let's see. We have to apply this calculation everywhere. And in the question, when this type of the condition will be there, remember that the percentage of such type of the particles will be always given to you. So these type of the particles having 35 atomic mass, total chlorines 75% is these type of the particles. and the particles having atomic mass 37, these type of the chlorine particles are only 25%. So you cannot ignore this 25%. So what we have to do then? We have to do a small calculation. Now let's see how we will do this calculation. So let's move to the next slide to do the calculation. Now see, I'm doing the calculation for you. Calculation will be done in this way, that the question will be given to you that 75% of chlorine particles have atomic mass 35 and 25% of the chlorine particles have atomic mass 37. So in the calculation of isotopes, relative atomic mass you have to calculate. So you do not need the atomic number. Just forget about the atomic number. So how can we calculate the relative atomic mass? So we will do in this way, 75% of chlorine particles have atomic mass 35 plus 25% of chlorine particles have atomic mass 37. Now let's do the calculation. 75% means 75 by 100 of 35 plus 25%. Percent means out of 100. Per means out of, cent means 100. Of means multiplied, 37. So if we solve this one will be 26.25. And if you solve this one will be 9.25. If you will add these two, it will be 35.5. This is the reason that we say that in the periodic table, the atomic mass of chlorine, you will find 35.5. So this question might come in the exam, that show with the help of calculation why the relative atomic mass of chlorine is not a whole number. So the relative atomic mass of chlorine is not a whole number because it exists in two different isotopic forms. So this is how you will show the calculation. Now, let's move to the next example. And if you will understand these two examples with calculation, rest, whatever the calculations will be given to you, whatever the percentages of whosoever element will be given to you, whatsoever element will be given to you, you will be able to do. All right. Now see, we have now copper has two isotopes. You can see both of the isotopes have atomic mass 29. 29, 29. But one has atomic mass 63, the other has atomic mass 65. And now they are saying that the copper with atomic mass 63 is 69%. So calculate the relative atomic mass. So this one is 69%. This one is 69%. How we will understand the percentage of this one? How we will do the calculation? Consider that both of them together makes up 100% of copper, out of which 69% of copper have atomic mass 63. So 100 minus 69 will be 31. It means the rest 31% is copper 65. Now let's do the calculation here. We will do it in this way. 69% of copper particles have atomic mass 63 plus 31% of copper have atomic mass 65. So 69 by 100 into 63 plus 31 by 100 into 65. So this one will become 43.47 plus this one will become 20.15. So the relatives, to remember in the exam, you have to keep your answer up to 2 decimal places. And then we can show that approximately, since after decimal the value is more than 50, so approximately it is 64. So this is how we do the calculations of the isotopes. This is an easy topic. I hope you all have understood and enjoyed the topic. See you in the next class. Bye.